Hello my students, welcome back. Welcome to sub lesson where we're going to learn about nets of geometry solid. Now what is net? Now you notice that, let's say for example, if Mr. Mac to take a prism, okay? Now this is in the form of what? 3 dimension. If I to take a scissors, alright, and then start cutting this by the edge and then open them out, and that's what's called net, and that says 2-dimensional, okay? So that's what we're going to learn, alright? So we're going to cut 4 shapes, alright? Which will be the prism, the pyramid, cylinder, and the cone. So we're going to cut them open and look the net, alright? So we're going to see the 2-dimensional part of it. So when you take the 2-dimensional, when you fold it, it becomes a 3-dimensional. See that? Alright, let's do that. Let's do the first one. Okay, so we're going to take the scissors, alright? So Mr. Mac, let's say I just cut it, and then I'm just going to cut there, and then I cut it through, and then I cut it through here. Look at that. Oh, I dropped it. I dropped it. Okay, so when I cut it all that sides, and look what happened. See the shape? See that? So you got 1, 2, 3 sides, and these are the base. See that? So this is what you call net. Alright, so you should able to, like in this case, when we got 3 sides, polygon, alright, you got 3 surfaces, alright. If the base is 4, so it'll be 4 sides, alright. If there's a polygon is 5, you're gonna have a 5 rectangles. See that, all the rectangles, alright. So make sure you understand. So the key thing is, you got 2 triangles in this case, with how many rectangles? 1, 2, 3. Now what happened if this is a quadrilateral? Now that 4 sides, so we have how many rectangles? That will be 4. If it's a 5 polygon with the 5 sides, it will be 5 rectangles. Alright, okay, good. So now you understand how when you cut open a prism, the net will look like this. Alright, okay, now let's look at a pyramid. Okay, here we are, got a pyramid right here. Now look at this. The pyramid also has edges, alright? We're going to cut by the edges, alright? That's what Mr. Mac's going to do. I'm going to take a scissors, I'm going to cut by the edges, alright? Let's say I'm just cutting it, okay? Actually, when Mr. Mac made it, I just taped it, but I'm just going to pretend like we're cutting it, alright? Okay? So I'm just cutting the tapes. Alright, there we go. Once I cut the tape, the edges, look what happens. See that? You got the base, the square, okay, the square base with how many sides? 1, 2, 3, 4 sides, and all of them are triangle. Alright, so keep in mind, now the base can be polygon, alright, now so it has to be square. It can be 5 sides, 6 sides, okay, and then based on the number of sides, that's how many number of triangle that you're going to have. Okay, so very important. Okay, you'll have the number of triangle based on the sides of the base. Alright, so now look at that. Alright, so you got 1, in this case how many triangles we got? 4. 1, 2, 3, 4, and then because it's a rectangle. Okay, alright, good. Okay, so now let's look at a cylinder. Alright, Mr. Mac got a cylinder. Alright, let's say for example, Mr. Mac got the cylinder right here. Okay, then what Mr. Mac did is I made a skin for that cylinder. Alright, so that way we can have like this right here. Alright, so now look at the cylinder right here. Now if Mr. Mac to cut this sides, alright, let's say if take a scissor right here, and then I cut the base, I cut the base, see that, and then I cut right in the center of the surface, okay, the side surface. Now look what happened. Right there. See that? You got 2 circle and a rectangle. Alright, from the cylinder. So it's very important to understand, okay, from a 3-dimensional, when I convert that into 2-dimensional, which is the net of a cylinder, you got 2 circle and a rectangle. Alright, so make sure you understand that. Alright, okay, good. Then we start put that away. Now let's take a cone. So what happened with the cone? If I to cut around the circle and then slide it right there. Okay, can I slice it? Okay, so that will pretty much look like this. Mr. Mac also create a skin. Okay, let me put that around it. Okay, so as you can see, okay, Mr. Mac created a skin out of a paper, and then you can notice that's on the base and then the surface. Okay, when I cut it around it, and then I gotta circle the base, and then when I slice on the side of it, and look what happened. And that's for the cone. See that? Okay, so you'll have a sector like a sector of a circle. See that? A sector and then a circle on the bottom. Alright, okay, good. So you see that? How the two-dimensional of a cone versus the three-dimensional of a cone. Alright, okay, now let's take it to the board. Let's start with the prism, okay? So we're going to look the net of the prism. Okay, let's start with the prism. Now, earlier we looked at the base is what? 3 sides, alright? 3 sides. In other words, they are triangular, alright? So let's draw a triangular. Now the way to draw a prism is you draw one here, one base here, and another one right here. But always keep in mind the one that's going to be hidden, put it in as a broken line, alright? The one's going to be hidden, put it as a broken line. Alright, so this is one way of doing it, do a straight line and then you can just erase it, okay? And then join them by vertex to vertex, like this two triangle are congruent, alright? So this vertex joins with that vertex, okay? And that vertex joins to that vertex, and then the hidden one, you put it as a broken line. Always keep in mind, whenever you draw a 3-dimension of a solid, the hidden sides are always show as a broken line, okay? The hidden line show as a broken line, okay? Because that way you know it's in the background. Alright, now look at that. This is the triangular polygon, alright? So you got 3 sides. And then how many surfaces? 3 surfaces. You got one rectangle right there, another rectangle, 2, and then 3, okay? Facing down. Now what happened if I convert, let's say change the base in another form of polygon with let's say 6 sides, hexagon, alright? So how do we draw that? First, you put the one side of the hexagon, okay? Alright, because we know that there are 6 sides, 1, 2, 3, 4, 5, 6, and then draw another one on this side, okay? So, okay, 1, 2, 3, and you know that the other 3 is going to be hidden, so I'm going to put it as a broken line, alright? Okay, put it as a broken line, and then I'm going to join. Now keep in mind, these 2 bases are congruent, so I'm going to join them from vertex to vertex, okay? So I'm going to join that, I'm going to join that, I'm going to join, and then the join. Now the hidden one, I'm going to put it as a broken line, okay? This joining to that, I'm going to put it as a broken line, and this joining to that one, I'm going to put it as a broken line. See that? Turns out to be a prism right there. Now, what happened if I cut open this? So keep in mind, see the base, how many sides does the base has? 6 sides, alright? That means how many surfaces are there going to be? Rectangle surfaces. They're going to be 6 rectangle, alright? So when I cut it open, so let's start with the base with the polygon, which has the 6 sides, and then you're going to have a 1, okay? So you're going to have 1 surface, and then you're going to have a 2, and then you got 3, and then you got a 4, and then you got a 5, and then 6. Okay, what is missing? Another polygon right there, another hexagon. So 1, 2, 3, 4, 5, and 6 right there. Okay, see that? So you got 2 sides to the base of the polygon, alright, and then you got 1, 2, 3, 4, 5, 6 surface rectangle, and they all are equal. If this is the equal polygon, equal side polygon, and that will create an equal rectangle. So this rectangle is equal to that. In other words, all this length are going to be equal, and all this are going to be equal. Okay, see that? I'm using the 1 line and a 2 line to represent the sides. Okay, so this length and this length are going to be equal. Alright, so pretty straightforward, isn't it? So in other words, if I have to give you any form of a prism with a different polygon, you should be able to tell how many surfaces are. Okay, this is going to be a, let's say, octagon. Octagon has 8 sides. If the polygon is on the base are octagon shape, which has 8 sides, how many rectangle are they going to be? Exactly, it's going to be 8 rectangles. Alright? Alright, good. Alright, let Mr. Mac erase the board and let's talk about the pyramid. Okay? And I'll be back within a few seconds. Alright, my dear students, now we're going to learn more about the net part of the pyramid. Okay, so we know this is how the pyramid looks like. Okay, so Mr. Mike has already cut it open, so you know that. In this case, the base is what? A rectangle. Okay, let's put a rectangle base. Okay, I'm just going to draw it without a broken line yet. After I've drawn, and then I'm going to, okay, then right there. Okay, so now I'm going to put a broken line. This one's going to be a broken line, and that one's going to be a broken line. See that? Okay, so as you can see, the base is a rectangle, and you got triangle, okay, and it all converge into a vertex. All right. Now, if I had to cut open, so it will be a square, and then I got 4 triangles. See that? 4 triangles. Now, keep in mind, if it's a square, all these are going to be equal. All right. Okay, so equal, and then these are going to be equal. Very important, okay, to understand that. Now, what happened if it's let's say 6 sides? All right. In other words, the base is going to have a polygon of 6 sides, which would be what? Hexagon. All right. So, in other words, we got 1, 2, 3, 4, 5, 6, and then you're going to have a triangles right there, right there. See that? So then you just fold it. You fold it, and then it become like, and then converges into the very top and become like a vertex, kind of like this one right here. See that? And it converges and become like a vertex like this. Okay, kind of converges and become like a vertex. The same thing will happen to this one, except that in this case, the base has a polygon that with the sides of 6 sides. All right, so that means you're gonna have 6 triangles. If it's 8 sides, the base is 8 sides with the octagon. How many triangles? There will be 8 triangles. All right, pretty easy, isn't it? Very straightforward. Okay, and keep in mind, all these sides are going to be equal length. All right, and then this one's going to be equal length. All right, not necessarily this is going to be equal. All right, not necessarily. So it can be, if it's been specified that all the sides are equal, then yes. If not, you cannot make a judgment saying this side will be equal to that one. Not necessarily. All right, because sometimes you can have a cone, a pyramid that's a long pyramid like this. See that? You can have a long pyramid like this, like that. So in other words, this length is not necessarily has to be equal to that length. Okay. All right, good. Well, that's on the pyramid. Okay, so that's on the pyramid. Okay, good. Now let's talk about the cylinder, and I'll be back within a few seconds. All right, my dear students, now let's talk about cylinder. Okay, now for cylinder, and you know that it's a 2 circle. Okay, all right, and then right there. And then on the background, with the hidden one, you put a broken line like that. So when we cut it open and cut it right here, sliced it right there. So you got what? A rectangle with a 2 circle, because that's for the base and the top. See that? All right. So keep in mind. So it's a rectangle. Okay. So I know Mr. Max not drawing it by scale, but just keep in mind, it's a rectangle. All right. So this side and this side are equal length, and this side and this side are equal length. All right. Okay. So, but we'll learn more about the characteristic. Okay, how this length is going to equal to that. We're going to talk about that later. All right. But right now, I just want you to able to understand the net part of the cylinder. Okay. So when I had to cut open. So all right. Okay. That's pretty straightforward. And then let's look at the cone. And we know that with the cone. So the cone, right there. Okay, so when I cut this side, the base open, and then sliced it right there. So you have like this, and then a circle. Now keep in mind, this is a sector of another circle. If I draw a circle with this one as a center, right there. That's how that is. Okay, and this is a totally different circle. Okay, so that the radius for this one is different than the radius of that one. So they're 2 different radius. But keep in mind, this is the shape right there, and the circle right there. All right, pretty straightforward. Okay, like for example, with the prism and pyramid, we can have a different shapes, I mean based on the polygons, okay? But in this one it's pretty much straightforward. Cylinder like that, there's no other thing right there. Two circle and a rectangle, or square, it could also be a square, okay? So now on the cone, it's going to be pretty much a sector of a circle and a circle. Alright, that's it right there. Okay, alright, good. Well, let Mr. Mac erase the board. Let's do this. Let's do hands-on practice this way. Let's not call Pablo out. Mr. Mac's going to draw a few net diagrams and you label it. You tell me what shape it's going to come up to be. What three-dimensional. You fold it, the two-dimensional into three-dimensional. What is it going to turn out to be? Shall we do that? Alright, give me a few seconds. I'll be back with you. Alright, my dear student, I got 4 drawings, okay? I want you to state the geometry solids that represented by the net below here, okay? I got 4 different nets drawn. I want you to label them, alright? Mr. Mac's going to step out, you step in and have fun with it, okay? And then I'll invite Mr. Mac in and then we'll do it together, alright? Alright, here it is, have fun. How was it? Pretty easy, isn't it? Okay, let's do it together, okay? Okay, let's look at the first one. Now, the first one, what could that be? Exactly, it's a cone, alright? It's a cone, alright? It's a cone. Now, you wonder, well, Mr. Mac, why is it that way? It means a bigger cone. Let's say, for example, Mr. Mac, an example I'll show you, okay? Now, look at this. This is also considered a cone. Look at that. Alright, it's a hat, alright, okay? The farmers, those days, they use it, especially when they work in the party field, alright? See that? If I to cover the base also, it becomes a big cone, see that? So if I to cut this, and you can see, it will have a bigger one, alright? And of course, when it's a small cone, it looks like this. More sharper, alright, like this one right here. Can you see the difference between this and that, alright? Okay, so it looks like pretty much not too much of a difference of the height, but because the circle is bigger. When the circle is bigger, and you'll get the circle sector will be bigger. See that? A bigger sector. Okay, it'll be a major sector instead of minor sector. This create a minor sector, and this create a major sector, and that's how it looks like that. All right? Okay, good. And what about number 2? Number 2, it's a cylinder. Exactly, it's a cylinder. Very good. Okay, cylinder. All right, pretty straightforward, isn't it? You got 2 circular and then either rectangle or square. Okay, surface. All right, so that makes it a cylinder. Now, what about number 3? Exactly, it's a prism. All right, because prism has the rectangles. All right, or square. You can either have a square or rectangles, sides with a 2 base, a congruent, and they're polygons, all right? And that is a prism. Okay, good, prism. And what about 4? It's a pyramid, that's right. And it's a 1 base. When you got all this triangle, it's a 1 base with a triangle, and when you join them all together, and it converges into a vertex, okay? So this is a pyramid. Okay, and this pyramid has 8 sides, octagons, alright? Octagon. Alright, the base is an octagon. Wow, pretty easy, isn't it? Good. I want you to understand the net, alright, of the solid geometries. Okay, good. Wow, I'm so happy that you are able to label all these nets to the geometry solids, okay, which that's represent, each net represent to the geometry solids, alright, good. So you know how cones look like in a form of 2 dimension, cylinder, and then prism and pyramid. Alright, good. That shows you should ready for your next sub lesson. There is no quiz on this sub lesson, and we will see you next sub lesson. It's going to be a fun one. Alright, my dear student. Bye bye.